Welcome to Brain Vision.
Right, so for this problem, we are given the components of the magnetic field, and we know that this particle is moving with speed v in the negative y direction. So we can write the velocity vector as negative v times j. So for calculating the Lorentz force, we can directly apply its definition, which is qv cross b and then we can simply calculate the determinant of this 3×3 matrix to find out its components. So it turns out that F equals negative QV BZ times I plus QV BX K. So for part B, if Q is greater than 0, what must the signs of the components of B be if the components of F are all non-negative? So we know that Fx should be greater than or equal to 0, and Fz should be greater than or equal to 0, and Fy is already 0. So the sign of By doesn't matter. So from this we get Bz should be smaller than or equal to 0. Bx should be greater than or equal to 0. And By can take any sign. And finally, for part C, if Q is smaller than 0 and all the components of the magnetic fields are the same and they are greater than 0, we just find out the direction and magnitude of F. So when Bx equals Bz, we can simply rewrite F as negative QV Bx So if we plot this vector in xz plane, since q is smaller than 0, then the x component is greater than 0, and the z component is smaller than 0. So f should point to this direction with an angle 45 degrees with the positive x-axis, and the magnitude of f should be square root fx squared plus fz squared, and it turns out to be, since fx equals fz in absolute value, so this is just square root of 2 times absolute value of q times BBX.